Imagine a world thousands of years ago, long before modern technology, where people relied on the stars to guide their way. This was ancient India, a land of incredible knowledge and wisdom. Our story begins here, with the brilliant minds who looked up to the night sky and sought to understand its secrets. These early astronomers weren't just dreamers, they were meticulous observers and gifted mathematicians who made groundbreaking discoveries. In ancient India, astronomy was more than just a science. It was woven into the very fabric of daily life. The night sky held a great significance in Hinduism and other Indian religions. Celestial bodies like the sun, moon, and the stars influenced everything from agriculture to religious rituals. People believed that the movements of these heavenly objects could impact their lives and decisions. One of the earliest periods where we find traces of this astronomical knowledge is the Vedic period. During this time, ancient Indian scriptures such as the Rig Veda and Atharva Veda were composed. These texts are filled with references to celestial bodies, showing how deeply astronomy was embedded in the spiritual and cultural life of the people. Hymns and chants often praise deities associated with the sun, moon, and the stars, highlighting their importance in the universe. Our journey through the history of Indian astronomy wouldn't be complete without mentioning Aryabhata. Born in 476 CE, Aryabhata was a true pioneer who calculated the length of the solar year with remarkable precision. He also proposed the revolutionary idea that the Earth rotates on its axis. His work, documented in his famous book Aryabhata, laid the foundation for many future discoveries in both astronomy and mathematics. Next, we meet Brahmagupta. Born in 598 CE, Brahmagupta made significant contributions to our understanding of gravity and planetary motion. His remarkable work on lunar and solar eclipses showcased his mathematical brilliance and deep understanding of the cosmos. Our story will also introduce you to other influential astronomers like Varahamihira, Bhaskara I, and Bhaskara II, who made tremendous strides in trigonometry, calculus, and planetary motion. Their contributions left a lasting legacy that continues to inspire scientists today. Picture yourself in ancient India, thousands of years ago, where the night sky was a canvas of twinkling stars and planets. The people of this time were deeply connected to the cosmos, finding meaning and guidance in the patterns they observed. This is where our story begins, during the Vedic period, a time when astronomy was interwoven with spirituality and daily life. The Vedic period, which dates back to around 1500 BCE to 500 BCE, was an era of profound knowledge and wisdom. The ancient Indian scriptures from this time, such as the Rig Veda and the Atharva Veda, are treasure troves of astronomical references. These texts reveal that the early Indians were keen observers of the sky, recording the movements of celestial bodies with remarkable accuracy. The Rig Veda, one of the oldest known texts in human history, is filled with hymns that praise the gods associated with the sun, moon, and the stars. The sun, or Surya, was revered as the source of all life, its daily journey across the sky symbolizing the eternal cycle of birth, death, and rebirth. The moon, or Chandra, was also significant, influencing the rhythms of time and seasons. One of the most fascinating contributions of the Vedic period to astronomy is the concept of timekeeping. The ancient Indians developed a sophisticated calendar system based on the lunar and solar cycles. They divided the year into 12 months, each corresponding to a specific phase of the moon. This calendar not only helped them to keep track of agricultural activities, but also played a crucial role in religious rituals and festivals. The Atharva Veda, another important text from this period, contains numerous references to celestial events like eclipses and the movements of planets. The early Indians believed that these events were not mere coincidences but had deeper cosmic significance. They saw eclipses as powerful omens often associated with the actions of gods and demons. The priests and sages of this time would perform elaborate rituals to appease the gods and ensure the well-being of the community. The nakshatras, or lunar mansions, are another key element of Vedic astronomy. The sky was divided into 27 or 28 nakshatras, each representing a segment of the moon's monthly journey. The nakshatras were personified as deities and played a crucial role in astrological predictions. The position of the moon within these nakshatras at the time of one's birth was believed to influence their destiny and character. As our story unfolds, we see that the Vedic period laid the foundation for a rich tradition of astronomical knowledge in ancient India. The early Indians were not just passive observers of the night sky. They actively sought to understand the cosmos and its influence on their lives. 5th century CE. In a land brimming with intellectual curiosity is where Aryabhata's story begins. Aryabhata was born in 476 CE in a small village called Kusumapura, near present-day Patna in Bihar, India. Even as a young boy, Aryabhata exhibited a remarkable curiosity about the world around him. His keen mind and thirst for knowledge led him to study under the best scholars of his time. As he grew, Aryabhata's passion for mathematics and astronomy flourished. By the age of 23, he had written his magnum opus, the Aryabhata. This groundbreaking work, composed in Sanskrit, was a comprehensive treatise on mathematics and astronomy. It was divided into 4 sections: the Gitikapada, on time and its measurement, the Ganitapada, on mathematics, the Kalakriyapada, on astronomy, and the Golapada, on the sphere. The Aryabhata was a testament to Aryabhata's genius and laid the foundation for many future discoveries. One of Aryabhata's most significant contributions was his accurate calculation of the solar year. He determined that the length of the solar year was 365.358 days, which was very close to the modern value of 365.256 days. This precision was achieved through meticulous observation and mathematical prowess, demonstrating Aryabhata's exceptional understanding of celestial mechanics. But Aryabhata didn't stop there. He also proposed the revolutionary idea that the Earth rotates on its axis. In a time when most people believed that the Earth was stationary and the heavens revolved around it, Aryabhata's suggestion was groundbreaking. He explained that the apparent motion of the stars and the planets could be attributed to the Earth's rotation, a concept that was far ahead of its time. Aryabhata's contributions to mathematics were equally impressive. He introduced the concept of zero as a placeholder and used it in calculations, a practice that would later revolutionize mathematics. He also developed methods for solving complex algebraic equations and worked on the approximation of pi, estimating it to be approximately 3.1416, which is astonishingly close to the true value. In his Aryabhata, Aryabhata also tackled the problem of calculating the circumference of Earth. Using his knowledge of trigonometry, he estimated the Earth's circumference to be about 39,968 kilometers, which is very close to the actual value of 40,075 kilometers. This achievement demonstrated not only his mathematical brilliance, but also his ability to apply theoretical knowledge to practical problems. Another of Aryabhata's major works was the Arya Siddhanta, although much of it has been lost to history. What remains of this text reveals Aryabhata's deep understanding of planetary motion and eclipses. He accurately predicted solar and lunar eclipses and explained their causes, attributing them to the shadows cast by the Earth and the Moon. Aryabhata's legacy extends far beyond his own time. His works influenced generations of Indian and Islamic astronomers and mathematicians. His innovative ideas and precise calculations laid the groundwork for future discoveries and advancements in both fields. Now let's delve into the remarkable life of Varahamihira, one of the most influential figures in ancient astronomy and astrology. Picture yourself in the early 6th century CE, in the vibrant atmosphere of Ujjain, a city renowned for its scholars and thinkers. This is where Varahamihira's story begins. Varahamihira was born in 505 CE, in a small village in what is now modern-day India. His early life was steeped in the rich traditions of Indian scholarship. From a young age, Varahamihira showed an extraordinary aptitude for learning, particularly in the fields of mathematics and astronomy. He was taught by his father, Adityadasa, a distinguished scholar in his own right, who recognized his son's prodigious talent and nurtured it with great care. Varahamihira's curiosity and brilliance led him to Ujjain, a city that was a hub of academic and scientific activity. It was here that he flourished, surrounded by the leading minds of his time. His intellectual pursuit culminated in the creation of his work, the Panchasiddhantika. This monumental work was a comprehensive compilation of 5 astronomical treatises, synthesizing the knowledge from various schools of thought. It included the Surya Siddhanta, Romaka Siddhanta, Polisha Siddhanta, Vasishta Siddhanta, and Paitamaha Siddhanta. The Panchasiddhantika was a testament to Varamihira's deep understanding and mastery of astronomy, and it provided invaluable insights into the astronomical practices of his era. But Varamihira's contributions were not confined to astronomy alone. He also made significant strides in astrology, an integral part of Indian culture and tradition. His most famous work in this field is the Brihat Samhita, a vast encyclopedia that covered a wide range of topics. from astrology and astronomy to architecture and even gemology. The Brihad Samhita was a reflection of Varahimira's encyclopedic knowledge and his ability to connect diverse fields of study. In the realm of astrology, Varahimira's contributions were unmatched. He provided detailed descriptions of planetary motions, lunar and solar eclipses, and their influence on human affairs. His astrological predictions and the interpretations were based on the meticulous observations and calculations, blending scientific rigor with traditional beliefs. Varahimira's work had a profound impact on later astronomers and astrologers. His innovative methods and comprehensive approach set new standards in the field. He introduced the concept of hora, an hour in astrology, which became a cornerstone of astrological practices. His influence extended beyond the borders of India as his works were studied and revered by scholars in the Islamic world and later in Europe. Varahimira's legacy is not just confined to his scholarly achievements, it also lies in the inspiration he provided to countless generations of astronomers and astrologers. His works have been preserved and studied for centuries, a testament to their enduring relevance and significance. Now let's travel back to the 7th century CE and meet one of the most brilliant minds of ancient India, Brahmagupta. Born in 598 CE in the region of Binmal in modern-day Rajasthan, Brahmagupta was destined to become one of the greatest mathematicians and astronomers of his time. Brahmagupta grew up in a society where astronomy and mathematics were not just academic pursuits, but integral parts of daily life. From a young age, he showed a natural aptitude for numbers and the stars. He was deeply fascinated by the mysteries of the cosmos and the mathematical principles that governed them. His journey of discovery and innovation was just the beginning. As Brahmagupta matured, his work began to take shape in the form of his magnum opus, the Brahmasputa Siddhanta, written around 628 CE. This monumental text, composed in Sanskrit, was a treasure trove of astronomical knowledge and mathematical theories. It covered a wide range of topics, from planetary motions and lunar eclipses to algebraic equations and geometric principles. Brahmasputa Siddhanta was a groundbreaking work that laid the foundation for many future discoveries. One of Brahmagupta's most remarkable contributions was his work on gravity. Long before Sir Isaac Newton's famous apple incident, Brahmagupta had already theorized about the force that causes objects to fall to the ground. He proposed that there is a force of attraction that pulls objects towards the Earth, a concept that was revolutionary for his time. Although his explanation differed from Newton's law of gravitation, Brahmagupta's insights were a significant step forward in understanding the forces that govern our world. Brahmagupta was also a master of eclipse prediction. He meticulously observed the movements of the sun and the moon, and his calculations allowed him to predict both solar and lunar eclipses with remarkable accuracy. He understood that the lunar eclipses occurred when the moon passed into the Earth's shadow, and solar eclipses happened when the moon obscured the sun. His work in this area was detailed in the Brahmasputa Siddhanta and showcased his profound understanding of celestial mechanics. He also wrote another significant work, the Khanda Kadyaka, which further expanded of his astronomical theories and provided practical guidelines for astronomical observations. This text was a vital resource for astronomers of his time and for generations to come. It included tables and calculations that helped in predicting the positions of planets and stars, making it an invaluable tool for celestial navigation and astrology. In addition to his work on gravity and eclipses, Brahmagupta made significant advances in the field of mathematics. He introduced the concept of zero as a number and used it in calculations, which was a revolutionary idea that transformed mathematics. He also worked on solving quadratic equations and developed methods for dealing with negative numbers, all of which were groundbreaking for his time. Brahmagupta's life and work were a testament to his brilliance and his relentless pursuit of knowledge. His contributions to the fields of astronomy and mathematics have left an enduring legacy, influencing scholars and scientists for centuries. As we reflect on his achievements, we are reminded of the profound impact that one individual's curiosity and intellect can have on the world. The story of Brahmagupta is a fascinating journey through the cosmos and the world of numbers, a journey that continues to inspire and captivate us to this day. Now let's meet Bhaskara I, an exceptional mathematician and astronomer from ancient India. Bhaskara I was born in 600 CE, and his remarkable journey of intellectual pursuit began in a small village in what is now modern-day India. From a young age, Bhaskara I displayed an extraordinary aptitude for mathematics and astronomy. His curiosity and keen observational skills set him apart from his peers. As he grew older, his passion for understanding the mysteries of the cosmos deepened, and he dedicated his life to studying the intricate workings of the universe. Bhaskara I's most significant contributions are encapsulated in his two major works, the Mahabhaskariya and the Laghu Bhaskariya. These texts are a masterpiece that showcases his profound understanding of mathematics and its application in astronomy. The Bhaskara, or the Great Book of Bhaskara, is a comprehensive treatise on astronomy. In this work, Bhaskara first meticulously detailed the motions of celestial bodies, the calculations of planetary positions, and the prediction of eclipses. His precise and methodical approach to these complex topics demonstrated his exceptional analytic skills. His insights into the movements of the planets and the calculation of their positions were revolutionary for his time. He developed innovative methods to determine the position of the Sun, Moon, and the planets at any given time. These calculations were essential for astronomical observations and had practical applications in astrology and navigation. One of Bhaskara I's groundbreaking contributions to mathematics was his works on trigonometry. In the Bhaskara, he introduced and refined trigonometric concepts that would later become fundamental to the field. His work on sine and cosine functions, as well as their applications in calculating the positions of celestial bodies, were really noteworthy. Bhaskara I's other major work, the Bhaskara, or the smaller Book of Bhaskara, is a concise yet comprehensive text on astronomy. This work serves as practical guide for astronomers, providing simplified methods for calculating planetary positions and predicting eclipses. The Bhaskara was widely used for astronomers and scholars for centuries, attesting to its lasting impact. One of the most remarkable aspects of Bhaskara I's work was his ability to connect mathematical theories with practical applications. He demonstrated how trigonometric functions could be used to solve real-world problems, such as determining the distance between celestial bodies and predicting the timing of eclipses. His work laid the foundation for future advancements in both mathematics and astronomy. Now let's move to Bhaskara II. Born in 1114 CE in the village of Vijayavada, present-day Bijapur, Karnataka, Bhaskara II was destined to become one of the greatest mathematicians and astronomers of all time. As a young boy, Bhaskara II was surrounded by an environment that fostered intellectual curiosity. His father, Maheswara, was a renowned scholar and astronomer who played a crucial role in nurturing his son's talent. Bhaskara II's early education was steeped in the rich tradition of Indian mathematics and astronomy. It wasn't long before his own genius began to shine. Bhaskara II's contributions to the world of mathematics and astronomy are immortalized in his major works, the most notable being Siddhanta Shiromani, Lilavati, and Bijaganita. The Siddhanta Shiromani, which translates to the crown of the treatise, is an extraordinary compendium divided into 4 parts: Lilavati, arithmetic; Bijaganita, algebra; Grahaganita, planetary mathematics; and Goladhyaya, sphere. This monumental work covers a vast array of mathematical and astronomical topics, showcasing Bhaskara II's deep understanding and mastery of these subjects. The Lilavati, named after Bhaskara's second beloved daughter, is a treatise on arithmetic that is both practical and poetic. Legend has it that Bhaskara II wrote this book to console his daughter, whose marriage was tragically delayed by a miscalculated time. The Lilavati is filled with engaging problems and solutions, presented in a way that captivates the reader's imagination. Bhaskara II's ability to make complex mathematical concepts accessible and enjoyable is a testament to his brilliance as a teacher. In Bijaganita, covering algebra, Bhaskara II delves into the world of algebra, introducing innovative methods for solving equations and dealing with positive and negative numbers. His work on indeterminate equations, specifically the Chakravala method, was groundbreaking and influenced future generations of mathematicians. Bhaskara II's algebraic techniques laid the foundation of modern algebra and demonstrated his profound mathematical insight. Bhaskara II's contributions to calculus were also remarkable. Long before the European mathematician Isaac Newton developed his theories, Bhaskara II had already made significant strides in this field. In the Siddhanta Shiromani, he presented concepts similar to differential calculus, including the notion of infinitesimals and derivatives. His work on the rate of change and principles of calculus was applied to various astronomical calculations, demonstrating its practical utility. One of Bhaskara II's most fascinating contributions was his concept of gravitational force. In the Goladhyaya section of the Siddhanta Shiromani, he proposed that objects fall to the ground due to a force of attraction exerted by the Earth. This idea was a precursor to the concept of gravity later formulated by Isaac Newton. Although Bhaskara II's explanation differed from Newton's, his insights were a significant step towards understanding the force that governed the motion of objects. Bhaskara II's work on planetary motion and eclipses was equally impressive. He developed methods to predict the positions of planets and calculate the timing of solar and lunar eclipses with remarkable accuracy. His keen observations and mathematical prowess allowed him to create detailed astronomical tables that were used by scholars for centuries. The legacy of Indian astronomy stretched far beyond its borders, influencing astronomers across different cultures and eras. As time progressed, the profound contributions of Indian astronomers like Aryabhata, Brahmagupta, and Bhaskara II began to resonate beyond the subcontinent. Their works were not only preserved, but also enriched the astronomical knowledge of later Indian scholars. These luminaries build upon the foundations laid by their predecessors, creating a continuous thread of astronomical brilliance. Meanwhile, the Islamic world was experiencing its own golden age of science and learning. As the Islamic Empire expanded, it came into contact with the rich intellectual heritage of India. Scholars in places like Baghdad, known for its house of wisdom, eagerly sought out knowledge from different cultures. The works of Indian astronomers were among the prized treasures that these scholars embraced. One of the key figures in this cross-cultural exchange was the Persian scholar Al-Khwarizmi, who lived in the 9th century. Al-Khwarizmi is often considered the father of algebra, and he was profoundly influenced by the mathematical and astronomical knowledge of ancient India. His work, Zich al-Sindhind, drew heavily from Indian astronomical texts, especially those of Brahmagupta. Al-Khwarizmi's contributions to mathematics and astronomy were instrumental in shaping the scientific landscape of the Islamic world. The preservation of Indian astronomical texts were greatly facilitated by the translation efforts of Islamic scholars. These scholars translated important works from Sanskrit into Arabic, ensuring that the knowledge would endure and spread. For instance, Brahmagupta's Brahmasputa Siddhanta was translated into Arabic and became known as Sindhind al-Kabir. This translation played a crucial role in transmitting Indian astronomical ideas to the Islamic world. The influence of Indian astronomy extended even further through the work of scholars like Al-Biruni, an 11th century polymath who traveled to India and immersed himself in its culture and sciences. Al-Biruni's deep appreciation for Indian knowledge led him to write extensively about Indian astronomy and mathematics. His work, Kitab al-Hind, provided valuable insights into Indian scientific achievements and helped bridge the gap between different cultures. The ripple effect of this exchange didn't stop in the Islamic world. The knowledge preserved and enriched by Islamic scholars eventually found its way to medieval Europe. During the Renaissance, European scholars rediscovered these ancient texts, which had been translated from Arabic into Latin. This reintroduction of Indian astronomical and mathematical knowledge significantly contributed to the scientific revolution in Europe. It's fascinating to see how the brilliance of ancient Indian astronomy transcended geographical and cultural boundaries, influencing generations of scholars and astronomers. The collaborative spirit of knowledge sharing between India and Islamic scholars ensured that these valuable insights would continue to illuminate the path of discovery for centuries to come. This narrative showcases the remarkable journey of Indian astronomical knowledge, from its origins in the Indian subcontinent to its profound impact on the Islamic world and beyond. It's a testament to the enduring power of human curiosity and the interconnectedness of our shared intellectual heritage. As our journey through the history of ancient Indian astronomy comes to an end, let's reflect on the brilliance of the scholars we've met. From Aryabhata's precise calculations to Brahmagupta's work on gravity and Bhaskara II's contributions to calculus, these luminaries shaped the way we understand the cosmos. Their discoveries laid the groundwork for many modern scientific principles and continue to inspire scholars today. The relevance of their work is evident in the way it influenced not only Indian astronomy, but also the broader scientific community across cultures and eras. Their legacy reminds us of the power of curiosity, observation, and the relentless pursuit of knowledge. As we look up at the stars tonight, let's remember the wisdom of these ancient astronomers and their enduring contributions to the field of astronomy. The stars are not just distant points of light, they are a testament to the shared human quest to understand the universe. Thank you for watching, keep looking up.